In this section, what we're going to be doing is looking at solving trigonometric equations and the ways in which they can become a little bit more challenging as you go. So we're going to start with a couple that are pretty similar to one that was actually asked earlier when introducing all of these ratios on your XY plane. So we're going to start by solving for all angles in 0 to 2 pi. So that's basically the same as 0 to 360. So in that first unit circle, if you want to think about that, right? So it should be somewhere in here. So 0 to 2 pi. So that's cos theta equals -1/2. Okay, so to solve these, we can use a little trick called the cast rule to help us figure out which quadrants our solutions are going to exist in. So the cast rule is just a little mnemonic to help you remember what goes where, but you do have to know how to start and write out cast. So in the first quadrant, the top right quadrant, all trig ratios are actually positive here. And it's because they're made up of the x and the y's, which are both positive in that quadrant. And the hypotenuse of the r is positive everywhere. So in the second quadrant, which is labeled as S here, only sine is positive. And again, it's all going to come from just rewriting out these ratios, which I'll do. So if we have a sine theta is going to be y over r, cos theta is x over r. So cos theta is actually be negative in that ratio because of the x is negative, and tan theta is y over x. And in this quadrant, y is positive, but x is negative. And then the t, both y and x are negative, and so they're going to cancel each other out. And in the c, the x is positive, but the y is negative, which means that only cosine is positive, and the remaining sine and tan are going to be negative there. Okay, so to solve this first one, hold on, just trying to move this thing over. So to solve this first one, cos theta is -1/2. We can use that cast rule to tell us what quadrant this thing is going to exist in. So according to the cast rule, what we're going to do is we don't want all of them to be positive because cos is negative, and we don't want cos to be positive. So it's going to tell us that it occurs somewhere in the left two quadrants. And so what we're going to do is draw the triangles in those two quadrants. And if you recall from before, there are rules to how we draw these triangles. So in particular, what we're going to do is use the positive, or just the x-axis to form the base of any of our triangles. And then we go up or down from there. And so in this case, we'll both go both up and down because we do need two triangles here. So I can draw my two triangles over here like this. So they should go down to the x-axis, never across to the y. And now what I'm going to do is set up my ratios for these interior angles. So for those angles there, so if I look at my, I could call it x over r, or we could think of these as my adjacent over hypotenuse, if you like. So my hypotenuse will be 2 in both, and my adjacent will be -1. And it makes sense that it should be negative because it's going towards the left. So the other thing I might want to have noted here are my special triangles. Okay, because we usually won't really be thinking of these as the XY points. I just replace that space with the special triangles. So that is going to be helpful to us. And so in this picture, we've got the hypotenuse 2 and the side length of -1. So that is going to correspond with the 30, 60, 90 triangle. That is going to give us that opposite of √3. And the bottom one will be -√3 because it is going down. But most importantly, what that's going to tell us is the angle in that triangle. So in that triangle, we're going to follow the picture. The angle that's opposite of the root 3, if I look at this picture here, opposite of the root 3, so my reference angle is the 60 degrees. So yeah, I didn't draw these to scale at all, like not even a little bit to scale. So it would be hard to get that number from just looking at the pictures. What we do is we use the orientations of the triangles to get these numbers. So my reference angle is 60. And now to put the two answers together, so the first one is going to be this angle here. So that's going to be 180 minus 60. And then the other one goes around and then plus another 60. So that'll be 180 plus 60. And so that's going to give me my two solutions. So 120 degrees and 240 degrees. It does specifically ask for answers in radians, so we should convert. So I will get theta is 120 is 2/3 of 180, so that'll be 2 pi over 3. And 240 is double 120, so it'll be 4 pi over 3. And so those are going to be my two answers for this. Okay, so tan theta equals 1. So same idea. I will set up my cast to try to figure this out. I want tan to be positive, so everything's positive in the A quadrant, and tan is positive in the T quadrant. And so that's going to be where I get my two triangles. So I'm just going to draw them. And I'll draw them in blue. So again, it should always go up or down to the x-axis, never across to y. So these are going to be my two triangles. So I need to find the reference angle in both. If tan theta is 1, that's the same as 1 over 1. So I'd have 1 and 1, or -1 and -1. Should be the ratio down there. But they are the same triangle, just kind of flipped around. And we can see that this is the 45-45 triangle. So I can write those angles in here. And that's going to tell me my two solutions to this. So theta is going to be 45 degrees for the first one. And then the other one is going to be the 180 plus 45. So 225 degrees. Again, convert those to your radians. 45 is 1/4 of 180. And then 225 is 5 of those. And so those are going to be our two solutions for this one. Okay, so for this one, it just asks for the domain of your theta to be a little bit different for this one, but it really is the same thing. So we're solving for all theta between -pi and pi. So again, that is a full circle. It just looks a little bit different this time. So now it's starting at -pi or -180 and making its way around to pi like this. So what that means is that we can think of our answers as going either in the positive direction or the negative direction. And so none of our answers should be bigger than 180 degrees, either positive or negative. It still covers a circle, but in a slightly different way. So for the first one, we have 2 sine theta equals 1. We've kind of already dealt with this. We're going to isolate sine theta. And that's sine theta is 1/2. We can use the cast rule to figure out where our answer is going to occur. So sine is positive. That means either the A or the S. And so we draw the two triangles up in that positive region. All right, and so anytime we draw these triangles, the general pattern is kind of like a bow tie, and then you just choose the portions of that bow tie that will get used. And I'll pretty much never draw these to scale because it's more important to use the reference angles to try to figure out what numbers go where. So solve for all theta between negative pi and pi. So sine theta is a half. That means my opposite over hypotenuse is 1/2. And then using those reference triangles, we could figure out the adjacent. That should be √3 and negative √3 because it's the hypotenuse is 2, 1. Yeah, so that should be 30 degrees. That's 30 is opposite the 1 in that triangle. And both of these are the same. And so we should be able to figure out our two solutions. So we have this one, which is 30 degrees, and then the other one, which will be 180 minus 30 degrees. This wasn't very interesting at all. It actually didn't matter whether or not we went into the positives or negatives, because they're both in between negative 180 and 180. And so those are going to be our two answers. Theta is 30 degrees and 150 degrees. Both of them are in the correct region, except that they're not in radians, so I do need to fix that. So 30 is 1/6 of 180, and 150 is 5 times that. Both of them are in the right region. So that's not very interesting. We'll try the next one. 3 tan squared theta equals 1. Yeah, we'll solve this the same way we would solve any equation for tan theta. So what we'll have is tan squared theta is 1/3, which means tan theta is plus or minus √1/3, which might look more familiar to us as, I might actually even do this. Actually, it doesn't really matter. Plus or minus 1/√3. So that's going to use some of the numbers we can see in our triangles. Now, because this is plus or minus, we might get two triangles here. So the plus 1/√3, tan is positive in quadrants 1 and 3. The negative 1/√3, well, tan is positive. We can cross those ones out, which leaves the C and the S. We actually will get basically that whole bow tie if we were to draw it out. So I'll draw my two triangles, and then the other two will go over here. And then if we're using that 1/√3, so I'd have one that's opposite over adjacent, and then on this side they should be both negative. And then we know the hypotenuse is 2 in both cases. And so this one should be 1/negative √3 and negative 1/√3. And in all of these triangles, it will be the side in the 30/60 that's opposite of the 1. So that is going to be a reference angle of 30 degrees. In fact, for all of them. So it's all pretty much the same triangle. And so we are going to get 4 angles here. So from on the left, we've got this one, which is 30. And then we've got, we have to go in the negative direction though, right? This is going to be too far in the positive direction. So we have to go in the negative direction. So that'll be negative 180. And then plus the 30 back in the other direction. So that will be negative 150. And then, so in this one, we're going to go, this angle will be 180 minus 30, because we go back a bit. So 150 degrees. And then for the other one, we're going to go in the negative direction. So that'll be negative 30. And so if we put the 4 of them together, I'll convert them into radians. It should be pi/6. And negative 150 will be negative 5 pi/6. 150 is 5 pi/6, and negative 30 is negative pi/6. And they're all in the right region, negative pi to pi. So those will be how we can write all of those answers. Okay, so just for the last type of solution set that we might be looking at is actually all theta in r. So this is going to use the fact that our trig ratios keep looping through the same values again and again and again. So just the two that we're going to look at here, first of all, sine theta is 1 over root 2. I can use my cast rule to figure out where that's going to be. So where all and sine are positive. So I'll draw my two triangles. And set up the 1 over root 2 and 1 over root 2. And we should be able to recognize that this one is, it looks like our 45-45 triangle. And so yeah, we'll just plug in the numbers for that. So what we're going to do for any question like this is we start by getting the solutions in a circle. Whichever circle you prefer, it could be the negative pi to pi or the 0 to 2 pi. And so in this case, my two solutions are going to be the 45 and the, that should be 135 degrees for that one. So pi minus a quarter pi. So we have those two solutions. And then what we want to do after that is now add all the rotations of a circle. So just for example, we have this one here. So there's that. But then we could do all sorts of other ways to get to that same place, right? We could do an extra rotation. We could do many, many, many rotations and just keep ending up in the same place. So what we have to do is add k times 360 degrees. And that's the same for both of these. So in degrees, if we were writing our answer in degrees, we would have, let's say, would be 45, or I want theta equals 45 or 135 degrees plus k times 360 in radians, which is probably what you will be asked. You'll have theta, so that would be pi over 4. We just convert all the degrees to radians, 3 pi over 4, and then plus k, 2k pi. 360 times k, so 2 pi times k, and that would give you your complete set of answers. So yeah, really the only difference from what we do before is add the rotations, add the plus 2k pi at the end. I don't like the way that's written. So for the next one, we have 2 cos theta plus 5 equals 3. If we solve this one, we end up getting 2 cos theta is 2, and cos theta equals 1. This one is a little bit dicey because of the number 1. First of all, like if you try to draw something whose cos ratio is 1, you get this triangle that looks like, let's try it here. Theta, we'd have 1 over 1. And so the only way to make that work is if the opposite height is 0. And so that's not really a triangle. What that actually looks like is like a pancake, basically. Like these two things are on top of each other. You might be able to get what your angle is from that. It should be potentially 0, but I don't want you to have to look at these pictures to solve this. My recommendation, instead of using pictures, is to use the graph. So we're going to specifically use the graph for sine theta or cos theta equals either 0 or plus or minus 1, or tan theta is 0 or undefined. So remember, if tan theta is 0, that means that sine theta is 0. And if it's undefined, that means cos theta is 0, because tan is actually just sine over cos. So if we use the graph, if I have a look at the graph of cosine theta, We know that it starts up at the top and goes up like this. And that would be 360 or 2 pi. And then it actually just keeps doing the same thing again and again and again. But where cos theta equals 1 is all those peaks. So cos theta equals 1 right at the initial values. We can find that by just grabbing it from the graph. That's actually going to be at theta equals 1, theta equals 2 pi, theta equals 4 pi, etc. So if we want to write out our solution set, we would write theta is 0 degrees plus the K360, which is just K times 360 degrees, or theta is 2K pi. So those are a little bit different because we don't get the triangles, but pretty similar once you get that first answer. I'm just going to do one more of these. Nah, I changed my mind. I'll save the other case for a different example.